Hello, everyone, and welcome to the fourth episode of this month on AWS Consumer Electronics. I'm Krishi, and this is Chris, and we're excited to have you on the show. So for those of you who haven't been with us before, we'll just introduce ourselves and then jump right into the solution that we're going to solve today. So Chris, do you want to introduce yourself first? You are muted, Chris.
Oh, classic.
Yeah.
Thanks for joining if you're new, and thanks for returning if you've been with us for quite some time now. So yeah, I'm Chris Sorden, Solutions Architect at AWS. Been here for 3 years now, and we both support customers in the high tech and semi space. And yeah, I'll pass it over to Christian.
Hello, I'm Krishi, and I work with Chris, and I am a solutions architect here at AWS. I joined within this year and have gotten the chance to work with a lot of manufacturing partners who are concentrated in building consumer electronics, building high-tech products that we use today. And so for those of you who haven't been with us before, please feel free to let us know that you're new and let us know where you're joining from. We've had viewers from all over the world, and that really helps us figure out how other people are using electronics and thinking about smart homes. And over the last 3 episodes, we've focused on specifically how to build a smart home and how to design specific aspects of a smart home device. And over the last episode, we designed a smart lock. So Chris, you and Brian did that episode. I was just going to give a quick overview, but feel free to jump in. But we designed a smart lock and learned how to, wow. Somebody's from South Africa. Hello. Hi, Radhika.
Welcome, Radhika.
Nice to see you. All right, so last episode, we built a smart lock, and we learned how to onboard devices and push out firmware updates. So that way, billions of devices could be updated, and the users could be notified that a firmware update has been pushed to their device. We're going to review that architecture really quickly because today we're going to be talking about how to upgrade that smart lock so it is AI powered. And the reason I wanted to do this is because last time on this show, somebody asked at the end of the episode, Ghana.
Yeah, welcome, Joshua. Great to have you.
Hello. I love that. Okay. So last time on the show, somebody asked, would you consider using a machine learning model with the lock? Sudan, we are getting a lot of amazing representation.
Welcome, Mohammed.
Yeah, hello. So would you consider using AI to power a smart lock? And we did some thinking about how that would happen and thought it would be interesting to explore that use case on this show. And while it may not seem like the most obvious fit to use machine learning and AI to power a smart lock, the truth is that the architecture patterns that we're going to go through today are going to be highly relevant to any device that you would want to use with AI, any smart device that you want to be creating. So for anybody who is setting up their own smart home and wants to learn about how you can use different AI, specifically Gen AI services, definitely stick around and drop in the comments what you are thinking of building. It would be helpful inspiration for later episodes in the show. Okay, so let's get into the actual talk. I'm going to share my screen. All right. Can everyone see my screen?
Yep, I can see it.
Okay, I'm just going to go into the lucid chart that I've designed, and we're talking about how this smart lock was designed. So we talked about the design and onboarding. So really quickly, just to review, we have a door lock, and we used IoT Core. And Chris, can you feel free to like jump in and provide the details? I wasn't part of this discussion.
Yeah, sure. Just keep building it out in terms of what you have here. But yeah, this is kind of what we talked about in terms of interconnection to getting your door lock to be able to essentially be able to communicate with AWS Cloud, right? So that's really where that AWS IoT Core acts as that doorman, if you will, to be able to make use of the protocols and be able to essentially move that data into the cloud. And then from here, we see that it also does handle the things that you as a user don't want to handle, like the IoT certificates, like policies, IoT thing, what is that? IoT thing generic, whatever that is. But certificate policies, yeah. So it's really just being that managed service for you to handle a lot of these things, especially when it comes to updates moving forward, right? So yeah, thanks for putting this together. Appreciate this. A good recap of what we went through last time.
Yeah, and then we also talked really quickly about how to push the firmware update. So, the firmware is a piece of code, supposedly, and we can use AWS Signer to authenticate and verify that piece of code before we push it to the blob storage, right? So we're going to use an S3 bucket for that. And then from there, if we want to be able to push that out to billions of devices, we want to automatically handle failures. We discussed using IoT device management to create a job. And then that job can let the device know, hey, we have a new firmware update, and it can go grab the firmware update from S3. So that's a really high-level recap of the overall smart home device that we discussed last time. And now, if everyone's okay, I'm going to jump over to, talking about how we can make this an AI-powered smart lock. So we have this door lock, and I want to do some quick requirements gathering on what kind of features we might want from this door lock. So I can't see the comments. So Chris, if there are comments, just let me know like verbally, and we can start populating this. But for those of you who do use smart locks at home, how do you currently use them? And are there some automated features that you have thought about putting into your smart lock if you could redesign it?
Yeah, feel free to put your comments in the chat. We can discuss.
Okay, well, while everyone's thinking, I know that if I were to have I don't have a smart lock. Chris, do you have a smart lock?
I do not, but I mean, thinking about some requirements I potentially would want is maybe like some sort of anomaly detection, like if it's being open at a weird time, like 4 a.m. Something that might point me in the direction of, oh, might have been a break-in, or this might have been like some sort of anomaly against the means. So that's one. And then if you have any other ideas from the viewers, feel free to put something in the chat as well.
Yeah, anomaly detection, that's a good one. I also, I'd like to know just the analytics or the patterns behind when I am leaving and when I am coming home. So I'm doing some kind of time series analytics would be helpful. And we're talking about a smart lock, but like that could be helpful. Both of these could be helpful for any smart device, understanding the rhythm of your home to better optimize energy usage, or maybe when it's the best time to update the firmware. So you can do it when most of the devices are offline, and you don't have to worry about bandwidth, all that stuff. So time series analytics could be a good one.
I think permissions also. Oh, sorry. Go ahead.
Permissions.
Yeah, permissions. I've had I had to get my floors redone in my apartment, so I had to let in different vendors into the house. So like permissions in terms of adjusting based off of like a certain user group to give them access maybe like during a set time. Like right, since I only want them there like when I'm when I'm not there. So 9 to 4 p.m. they have access to my door. They can be able to unlock it. Like stuff like that is what I would probably want an AI powered smart lock to be able to at least identify and then set from like a user access group perspective.
Oh, that's really interesting. Yeah. Permissions and maybe even like delegates.
Yeah, exactly. Yeah.
Like delegating those permissions. I'm trying to think. I know, obviously we can use rules to set permissions and delegates, but I think it's interesting to explore how we can use AI, and again, using the data access patterns for our normal entry and exit, and to maybe having the permissions and delegates inherit that same cyclical pattern. So, even though they've been given a permission to enter the house, maybe they can only enter it between like 9 to 4 or exactly. Something like that.
Yeah.
Okay, that's a good one. And then I'm trying to think, this is an interesting challenge to solve, but I know a common use case for AI is also chatbots. And one thing that would be interesting is using a chatbot within the app that is controlling the smart lock, or again, like this can be any smart home device, in order to troubleshoot.
Mm-hmm.
So if for some reason it's not working as expected, can I just chat with it, through my phone and get an answer without having to go onto the company's website, or without having to call, the company? Because you would definitely want to be able to troubleshoot your smart lock issues like immediately, since it's a matter of like your privacy. Be like less concerned about a light bulb not working than a smart lock. So maybe we can have like a troubleshooting chatbot.
Yeah, no, I think that's a great idea. I think I see a lot of functionality when it comes to that, in terms of even going back to the overall use case of being able to delegate and let people into your house as well. You can just be able to submit a message to your chatbot and say, hey, we have people coming over. Please unlock it for them. And then also when it comes to like just parts, maybe your door lock is running out of battery or whatever it may be, something needs to be replaced. It can be able to send you a trigger to potentially order parts for you. Like these are all things that I'm just thinking out loud in terms of how this chatbot functionality could play a role in an AI powered smart lock.
Yeah. Okay. Yeah. No, that makes sense. Any thoughts from the chat on interesting requirements or use cases?
Yeah. And depending on the lock itself, if there's video enabled, that can also create or introduce a lot more functionality there. But I think for the sake of this demo, I'm going to leave a video camera off.
But I'll write it as a note. I don't think we're going to tackle it today. And we may not tackle all of these requirements, since I think some of them might be a little bit more challenging, but we can at least put it as a note. So, streaming like the video content of like the outside, like kind of like a ring.
Like I was thinking more so like motion detection, or if you're mostly motion detection, and then for sure. So we might not be able to tackle that today, but definitely potentially like a future episode we can discuss more so like around cameras specifically. But All right,
Okay. Awesome. Okay, so we have some basic functionality that we would want to use for this AI-powered smart lock. And in previous episodes, we've talked about, how to host a smart lock and the phone application itself and the architecture. But for today, because the topic of Gen AI can be so huge, we're just going to focus on how to use like AWS cloud services to design some of these features. So that's kind of the main scope. And I think what would be reasonable is to talk about, how to use data, like for example, time series data for anomaly detection and maybe the chatbot. And if we have time, we can go into the permissions and delegates. So let's see how that would look. Okay. And before I jump into the Gen AI topic, has anybody used Gen AI outside of like smart home devices, and for example, like browser-based chat applications? Has anybody built any Gen AI applications on their own?
Yeah, we'd love to hear it. Just put your what you've built in the chat.
All right. As you all are thinking about that, I am going to start building out. Let's first talk about, since we just talked about firmware updates, right? Where, there's some new firmware, right? Some code, and we're storing it in an S3 bucket. And somehow those devices are made aware that a firmware update is available and can then go grab it, right?
Mhm.
So I think that would naturally lend into first talking about how to build a troubleshooting chatbot, because the actual functionality is, or the actual architecture flow is going to be somewhat familiar. So like what we're going to do is we're going to have an S3 bucket, and that will hold the device documentation. So in a similar way to an S3 bucket holding the firmware updates, we're going to have an S3 bucket that's going to hold all of these different, let's say we have PDF files that tell us how to set up the smart lock, what errors the smart lock can have, and stuff like that.
Yep.
And the first thing that we'd want to do is generate embeddings. So you can generate embeddings a few different ways. But if let's say we're using, we want to make this as simple as possible. We want to do as little work as possible. Then there is a service that we have called Amazon OpenSearch Serverless. And it has a feature that will automatically generate vectors, right? Generate embeddings from an S3 bucket. So to make this as simple as possible, we can just generate the embeddings by assuming we're using Amazon OpenSearch Serverless and generating embeddings using that tool. Have you ever used that tool, by the way, Chris?
I have had customers use the tool. Definitely very powerful in terms of scalability, especially when it's serverless as well. So, but I did want to show one question that we had from Mohamed.
Okay.
Can we implement this in a company? I mean, all employees are able to enter in working days, but not weekends. Yeah, you want to. So this can definitely be. This use case is really just meant for one smart lock, but obviously this can definitely scale depending on your overall use case, right? It's just a matter of centralized management. We can be able to have multiple locks within your building, but just for the sake of this episode, yeah, this is for one lock, but we can definitely be able to scale to be able to make this more of a enterprise level type of use case, right? So there's just more things involved in terms of like access control and centralized management between the different doors. But yeah, and there are, but yeah. Anything else you want to say on that, Krishi?
Yeah. So Mohan, there is in the architectures that we're discussing today, we're focusing mainly on AWS managed services. So and that makes scalability seamless. So, when it comes to implementing it in a company, there's different layers that you would want to discuss as well. Like you would want to make sure that you can discuss like the security and who has permissions and, all of the networking requirements and stuff like that. But the overall AI implementation is going to be the same as what we're talking about. So it really would just be about the other additional components when making it, enterprise grade.
Yeah.
And then the other thing is we just talked about Amazon OpenSearch serverless. So that will be able to scale as the number of users that are interacting with it scales. So that's where you can make a decision later on if you want to make it more robust to handle a larger company. Then maybe you would want to move into, just Amazon OpenSearch and use a different service to generate embeddings, which we can talk about as well if you're interested.
So I had another question from Qualhorst. Do you ever hire the open source authors of the cloud services? Just I think a bit confused on that question, but I see you have another one. Let me show your second one instead. Okay, Qualhorst as well has said, used serverless before and it keeps on trying to get me to upgrade my Python. Okay. Do you yeah, so I mean, Krishi, do you want to take that?
Yeah, I mean, the thing with using our managed services, then like serverless is it'll encourage you, or sometimes it'll make you upgrade so that you can have the latest security updates, or so that the service can use the most relevant version, because we keep the service up to date for you. That's part of the nice advantage of using managed services. So that does mean that you're going to have to, for example, upgrade the Python version if the version that you're on is out of date and not supported by the managed service. So
yeah, and also just trying to give you more functionality and flexibility as they push these updates as well. So making sure that you have latest and greatest for you to be able to build.
Exactly. Okay, so the next thing is, we have these embeddings. And for anybody who is new to Gen AI, embeddings are numerical representations of natural language, for example, in this use case. So we have this document, and now we've translated it into numbers that a model can understand. And then to actually build this chat app, we can use our Gen AI service, Amazon Bedrock, which is a managed service that allows you to ping API endpoints to third-party models and leverage those within your code, or your application. So you can spin up a Lambda function and ping a third-party model that's hosted on Amazon Bedrock, and that can use the device documentation, which is in that format that the model understands. So that's one way to kind of make sure that this user can use the mobile phone application to troubleshoot the smart lock problem using the original device documentation and Gen AI. So we can use that approach, but essentially the Gen AI model will need some kind of knowledge base. And in this approach, we're using vector embeddings and the documents stored in S3. But I wanted to also quickly share alternatives that are useful to know about. So you can also store information directly in DynamoDB. This would be really more useful for like unstructured data, like maybe user related data. So that could help with this permissions and delegates feature later on, or, very short like documents or text files. So I wouldn't necessarily use it for large PDFs because it's definitely not designed for that. It is a managed NoSQL database. And then we have Amazon Kendra, which allows you to do intelligent document search. So this is where you can host documents of different file types and be able to set that up as a knowledge base for Amazon Bedrock because it is integrated directly with Amazon Bedrock. So those are your alternative knowledge bases. So those are 3 different ideas for how you can feed information to a Gen AI model in order to help this user troubleshoot issues with the smart lock. And this is all things that we can add on to that smart home architecture that we've been building over the last few episodes. Okay, so I'm going to stop sharing that and we can move on to the next use case. If everyone's ready with that, I'm going to pause really quickly so don't brush past it. But Chris, what are you thinking so far?
Yeah, I think this is good. I think it's important to understand the different alternatives that Krishy had mentioned, and when you're actually building this in terms of pure scale overall your use case, like make sure you understand the trade-offs of each and the different capabilities in terms of when you would use Kendra versus potentially OpenSearch serverless versus another service as well. Since AWS, we have a ton of services to be able to help you capture your overall use case. It's just a matter of understanding the trade-offs between which one you might want to be able to go for. So if you, definitely, we have a lot of architecture diagrams and sort of blog posts going through the trade-offs. So definitely recommend looking into our documentation as well when you discuss or building any RAG-based architecture type use case. So.
Yeah, no, exactly. Okay, so that helps us get the troubleshooting chatbot. I don't know if you can actually check this off, but this helps us get the troubleshooting chatbot set up and gives us a pathway to also building maybe chat powered use cases for like permissions and delegates and user auth related functionality, since we can store that in a database and we now know how to query it along with documentation that could be relevant. So I'm going to clear the board now so we can talk about maybe how to generate time series analytics and anomaly detection. So Chris, I'm just going to get this set up, but can you tell me like what kind of anomalies can we like think of that we would want to catch on a smart lock? And also in the chat, like please give ideas on what kind of anomalies would be helpful.
Yeah, I think just a quick one that comes to mind is, potentially like unlocking your door at 4 a.m. if you haven't unlocked the door at 4 a.m. in the last month or so, like those type of anomalies. Potentially if it understands that you're out of, no one's in your house during like 9 to 5, like, and there's a check-in at 1 p.m. one day, that's an anomaly too in terms of past metrics. So things like that. And then also like maybe if you're tracking when your kids get back from school or or something like that. Like maybe it's anomaly if they get home at 4 p.m. versus 3 p.m. for the school bus, right? So these are types of things that I would think parents would want to be able to track if they're very stern on their kids getting home at some certain time, which mine were. So for sure my parents would want to calculate that. But yeah, those are some anomalies that I have had in mind.
Yeah. Okay. Yeah. No, I mean, those are all, I can't think of other ones. Those are actually really good ones. Well, actually, maybe one anomaly that I'd want to detect is if there was an issue in the smart lock and I didn't know that it was unlocking and locking things.
Oh, yeah, sure. Like failed attempts of, exactly.
Right. Yeah. So knowing that, like, hey, your device is having an issue, and then being able to use the chatbot to troubleshoot the issue would be like a good end-to-end way to use the different features that we're designing right now.
Yeah, that's great. Actually, just more so the troubleshooting. Maybe if the door was held open for like a minute or so, that's also an anomaly.
Yeah, and that could be helpful for, I think, one of who was talking, Mohanad was talking about how, they want to be able to maybe track like the smart lock for employees being able to enter in on certain days of the week. So that would be good to know that minute level information.
Yeah.
At that case where security matters, a lot more than, maybe just like a house in a really safe suburb.
Yeah, for sure. And another one that just came to mind is on the security front is if there's a lot of like someone is putting in all these PIN numbers to try to get to your door, and you see 30 different types of guesses to try to get in your door. Like these are also that we want to be able to be alerted back as a user. So
because these are things that you can't see really.
Exactly.
And you could have a video that detects it, but if the video is just catching the person's face, but not actually capturing the data that they're submitting into the lock, then it may not be as helpful. So I love that, actually, like catching the keypad and messing with that.
Yeah. I think that just gives you more visibility into what really is happening when you don't know it.
Okay, so this brings us into how do we actually capture the data in order to detect the anomalies, right? Because with anomaly detection, you first want to learn the pattern of how that smart lock is being used on a device basis. So this is where we are now going to talk again about how like IoT Core can collect data from this door lock, and we can stream the data using AWS Kinesis data streams or Kinesis Firehose, right?
Yeah.
So that gives us a way to stream data into our managed service, Amazon Kinesis Data Analytics. And what data analytics can do is it can apply some transformations. It can do some basic analytics to that incoming streaming data. And just moved it. And we can save that transformed, clean data using a storage option that I think the most fitting one here is going to be Amazon Time Stream, right?
Yeah.
So Amazon Time Stream is a time series database that is designed for handling this kind of IoT, time series related data. And it basically has the timestamp and the device ID, for example, if that's what you choose to log, as well as the metrics that you are pulling and saving. So this gives us a good foundation for capturing the users or the companies or the institution's patterns with the smart lock. Are there any other like storage options that you would consider, or any other like patterns that you would consider, Chris, for?
I would say I like what you have up right now in terms of a distributed one that can be able to scale along with your users. So none that comes up to mind right now, but
Okay.
I think this is well architected so far in what you have up.
Okay. And is there any questions so far coming in from the chat, or we're all good?
Oh, we actually have one.
Okay.
Hey, it's Mamu. Okay. Did anyone know what app service they're using for the infrastructure? Oh, Dragon. I think this is Lucid.
Yeah, this is Lucidchart. But there are a few others that are commonly used, but Lucidchart is helpful and it has the icons for AWS. Yeah, you're welcome.
Thanks.
Yeah, I'm glad I could help. Okay, so the next thing we want to do is we want to make sure that this chatbot can somehow interact with this time series database. So again, we're abstracting away the phone app hosting architecture because that's a discussion for, a different episode. But what we want to do is we want that app to then be able to use Gen AI to automatically query this database, right? So the whole purpose is trying to make this as easy to design and implement as possible, leveraging Gen AI services. And this makes it easier to focus more on, updating the firmware, improving the door lock, and giving better features to the user that we can be flexible and adapt over time.
Yeah.
So the way to design this would be, again, using Lambda, right, for serverless compute to then ping a third-party model hosted in Amazon Bedrock. And the advantage of this architecture option is that you can select the foundation model that you want to use to convert the natural language text, the question that the user has, into SQL and ping Amazon time stream, right? So this is kind of what it's doing. It's gonna take let's say it's like, hey, how many times a day do I open the door? Like let's say that's our question, which is not a really good question, but if anybody thinks of something more interesting, let me know because I'm just coming up with it. But if you wanted to know that, you would type that into the mobile app and in the chat, and then it would trigger a Lambda, which would then ping the foundation model that we as the developers of this AI-powered smart home chose, and that lets us experiment really quickly to see which model provides the best answer. But basically, the model is converting that question into a SQL statement that can pull the data from time stream. Now, if we wanted to also provide information on how to fix something, so like, hey, my lock is broken. I think I saw somebody come in at 2 p.m. Is that true? Like, we could use the time stream data using this flow to say, yes, somebody came in at exactly 2:02 p.m. and then ping the knowledge base to then get the device information.
Yeah.
Here's how you can fix your lock.
Yeah, it's like an intelligence layer on top of what we already have with the time series data. So it's very powerful, especially when you think of the troubleshooting type of cases where those anomalies, summarizing those anomalies back to you, and then positioning yourself to be able to actually take action on that anomaly, right? So, and it's very conversational too, right? So you have that conversational troubleshooting that makes it more seamless for you, the user, to be able to find these anomalies quicker and take action on them faster as well.
Yeah. And then there's a few different ways that you can create these AI-powered features, right? But the advantage of using Gen AI specifically with the 2 or 3 use cases that we're evaluating today is that it allows us to take a question that a user is asking, like in human language, and quickly convert that using a model that has already been trained. So we don't have to spend a lot of time training a model, validating that the model works, comparing model metrics, and then deploying that model, which is a whole other ballgame. And we can definitely talk about that in a future episode. Let us know if you're interested in that, because that is more involved, but also really interesting. But we can actually leverage, a managed service that has capabilities built for specifically Gen AI built into it to make all of that part really easy and focus more on maybe other components of the app. So that's kind of the main reason we chose to talk about Gen AI for today. And there is two options. This is option one for how to implement this kind of text to SQL pattern. And this option gives you more flexibility because you can choose the foundation model underneath, and you can integrate this solution directly within your phone app as is. So you're going to do more like coding to make sure that you're just going to create a new endpoint, and maybe you can design how that chatbot looks. You can integrate it with the original branding and design. But let's say you just want to, power the chatbot, and you're okay with using something that is already pre-designed and pre-built. So if we wanted to look at a different option, we can use another Gen AI service that we have, and that is using Amazon Q. And so Amazon Q is a way to easily leverage like pre-trained chatbots without having to actually worry about coding and designing. So it's built for plug and play use. And the way that we're using it here in this design is let's say we want to show a dashboard to the customer of let's say the customer asks can you show me how many times I opened my door for every day of this week? The best way to display that information would be through a bar chart, rather than kind of the chatbot writing every single line out. On Monday, you opened the door 3 times. On Tuesday, you didn't open the door. You should probably leave your house. Instead of that, we can use a bar chart that is built through Amazon QuickSight. But rather than having to write the SQL and come up with how the design of the bar chart should be, we can use Amazon Q on top of QuickSight, and that will leverage the data that's stored in Amazon time stream.
Yep.
Then, what were you going to say, Chris?
Yeah, I was going to say I deal with Amazon Q a lot, and some of the advantages of it, Amazon Q, is that it really is more of an easy button in terms of this conversational type of use case here. And there's a lot of pre-built connectors as well. If you're dealing, if it's more of enterprise use case, you can think that maybe you want to pull some data from Slack or from Confluence or other type of softwares where you want to be able to ingest things into Q. So Q offers that functionality as well to make it a bit more easier in terms of being able to deploy faster with more data sources like that. So, but Q and Bedrock, both very powerful services. Just depends in terms of how much control you want over some of the prompting and on the Bedrock side versus Q being more managed for you in that regard. So.
Yeah, no, that's awesome. And have you used Amazon Q with QuickSight to generate dashboards automatically for this kind of use case, Chris?
Yeah. That's really, there's a reason why it's, we call it Q suite of products, right? There's Amazon Q for business, Amazon Q for developer, and of course, Amazon Q itself, which is, so all of these are really, integrated nicely for each other. And then if you've ever used Amazon Q, it's really, really powerful in terms of now utilizing generative BI as well for the natural language querying within your dashboards, right? So now taking in Amazon Q for business or for developer, embedding it within Amazon Q dashboards, just best of both worlds in terms of what you can be able to do when it comes to like those proactive type of monitoring dashboards, reports that you want to be able to have back as an end user. So very powerful.
Yeah, it is super powerful. And the trade-off to keep in mind, I know for when people are first navigating, Gen AI services, and especially like our options for Gen AI services, the thing to keep in mind is how much flexibility you want when designing this AI powered feature for this smart lock, for example. So, does it matter if you can design the chatbot and it has to integrate like within the app structure itself, right? Amazon Q for Business can be like a really easy, like plug and play option to generate a chatbot quickly for your app, but it may not have the flexibility that you need. Do you need to be able to experiment quickly with different foundation models? Maybe you want to try Anthropic Cloud, maybe you want to try Llama, maybe you want to try Amazon Nova. If you want to be able to experiment and iterate and give your users the best possible responses that you can provide, then our first option, which I'm going to show here because I see a few new people joining in, your best option would be to go for Amazon Bedrock and give yourself the flexibility of experimentation and design, as well as some other controls. So I wanted to talk about these two options and how they differ, because they're really the backbone of building that Gen AI layer on top of your smart home lock or your smart home devices. So are there any questions on what we've talked about so far, or any ideas on other ways that you can use these Gen AI tools in order to power your smart home devices? Okay.
We got a quiet crowd today. No worries.
It's okay. So I know that we have these tools that we talked about, but I want to also mention that, there's a few layers that we can add on top of this to make things like, permissions and delegates easier, or even to add the ability to maybe detect motion later on, or to make sure that the correct, like that the user is authenticated, right? Security mechanisms. I'm trying to think of other things. We may want to have memory of previous conversations that the user has had, so it doesn't feel like the user always has to put in the same information into the chatbot. And so to do that, we would need to go beyond the knowledge bases that we've set up. We would want to create like memory, for example. We'd want to have an identity layer. And so with this setup here, right, this architecture that we're showing, where we're leveraging Amazon Bedrock to be, the brains behind crafting the responses back to the user, leveraging data stored in Amazon TimeStream for the smart lock. We would also want to maybe add memory storage, such as like, storing things and storing interactions in Amazon DynamoDB, or storing maybe documents that the user has uploaded, or pictures that the user has uploaded in Amazon S3. So that's one way to add memory. And then also using, IAM or like certificates to ensure that we have the security layer added on top. But to make this easier, recently AWS announced Amazon Bedrock Agent Core, and that is a service that allows like a one-stop shop for you to set up these different components of your Gen AI feature or product. So we didn't talk about Agent Core today, but if you're interested in seeing how we can discuss Amazon Bedrock Agent Core to elevate this use case, then we can also talk about that. So definitely let us know. But I wanted to mention that there were some other options. So
Yeah.
we can spend the last few minutes just doing some closing thoughts on this current architecture. We've talked about how to design a smart lock and how that smart lock can get the firmware updates, how we're onboarding devices. And then today what we did was we added on top of that architecture to give some AI-powered features to make this smart lock a little more intelligent, a little smarter, I guess. So we talked about how to do troubleshooting with a chatbot, right? So we set up the knowledge bases, and I can just share those architecture because we have actually time to kind of review that part. But we talked about, I'm just going to delete that.
Yeah, and I would say this as well. If you have never played around with any of these services before too, feel free to create an AWS account. We have free tier within a lot of these services as well. And we also have a lot of demos and workshops that you can be able to go through to get a bit more interactive with some of these services, right? So you can see the power and scale of how easy it would be to actually set up an Amazon Q chatbot, or how versus if you wanted to go the Bedrock route as well, playing around different models as well. So definitely a big advocate of playing around within the AWS console and kind of getting your feet wet in terms of some of the possibilities that potentially you might want to be able to think about moving forward for building whatever it may be, a smart lock, or like a smart light as well. So
yeah, definitely get started, and it's helpful even to start learning how you can set up a knowledge base and the different options we talked about. So you can just do basic document searching for a chatbot, even if you're not trying to connect it to a smart home. It's helpful to know because eventually you can kind of figure out how to improve it and then attach it onto your smart home devices or some consumer electronics product. And just so we can review, we talked about OpenSearch and then Kendra and DynamoDB as being potential sources for your knowledge base for Bedrock. OpenSearch and Kendra are integrated within Bedrock itself, and DynamoDB can be helpful for certain situations. And then we also talked about how to add the analytics, so that way we can do time series analytics for anomaly detection or learning patterns, or even for just asking questions, maybe how many times did the plumber come in, like that kind of stuff to give the information that you might need. So from there, we talked about collecting data using Amazon Kinesis data streams, doing some transformations using Amazon Kinesis data analytics, and then storing that in TimeStream. The easiest way for the user to talk to this database is for us to use a chatbot that they can just type a question into. So we wanted to we wanted to transform a naturally like spoken or typed question into SQL that TimeStream can then, use to get back data. So we integrated the chatbot into our app using Amazon Bedrock. And the other option that we talked about was using Amazon Q, and generating dashboards using Amazon QuickSight. So these are like two ways that you can use Gen AI on consumer electronics. And yeah, if there's no other ideas, then we can maybe brainstorm, how we would want to talk about either upgrading this smart home or smart lock, or we can talk about maybe what other topics would be interesting from a consumer electronics perspective.
Yeah. Yeah, just imagine it. This is just a smart lock, but just imagine your whole house has some sort of embedded, telemetry data giving information to IoT core, right? The types of use cases that you can be able to have, especially when it comes to like, lights, and when it comes to, just for one example, I leave the light on in my kitchen on all the time when I leave the house, and I would love if I got alerted back from my chatbot saying, "Oh, you left your light on again. Do you want me to turn it off for you?" Right. So
Yeah.
these are things that like very powerful, just types of things that I would actually use in my daily life that I don't have today. So what Christy had showed to you today is foundational type of architecture that can be applied not only just to a smart lock, but also like a smart light that you might be working on, or even something as more complex like a smart fridge, right? So there's a lot of cool use cases. If you got anything out of this today, I would love just for you to play around with some of these services. Sorry if you hear this. There's like some construction outside if you hear that noise, but yeah, thanks for taking the time, everyone on the stream today.